For the past year, Retrieval-Augmented Generation, or RAG, has been the quiet backbone of the AI world. It's the engine behind enterprise copilots, internal knowledge tools, and research agents. The rule was simple: don't rely on the model alone. Retrieve the right information at runtime and ground the response. But as long context models improve, a subtle structural shift is beginning to emerge. If a model can read much more in a single pass, how much of that retrieval layer is still essential? RAG isn't going away, but its role is changing from a hard dependency to something more situational. To understand this, we have to look back at the constraints that shaped the first generation of AI systems. Earlier models had strict context limits, often just a few thousand tokens. They simply couldn't read entire documents. RAG solved this by externalizing knowledge. Instead of retraining the model, we fed it fragments of data. This made systems dynamic and costs manageable. RAG wasn't chosen for its elegance, but for its efficiency under pressure. But once you scale these systems, the friction becomes visible. The first issue is context fragmentation. Fixed token windows break up information. A single argument might span multiple chunks, and the model loses the full structure. The second issue is accuracy. Embedding similarity is a proxy for relevance, not a guarantee. You often get nearby content that doesn't answer the question. This leads to re-ranking layers, which improve precision but introduce significant latency and extra costs. A production-grade RAG system eventually turns into a massive distributed engineering challenge. At scale, retrieval becomes a heavy operational expense. This was justified before, but long context models change the math. Modern architectures like flash attention allow models to process sequences that are orders of magnitude larger. Practically, this means entire documents can be passed in without chunking, preserving the original structure. Consider a financial analysis. Relevant signals are often scattered across commentary, risks, and footnotes. In RAG, you might retrieve snippets. With long context, the model reasons across the entire report naturally. Long context preserves the inherent discourse flow and logical continuity of complex documents. However, long context isn't a silver bullet. As sequence length increases, attention dilution becomes a real issue. Models can suffer from the lost in the middle effect, where they pay less attention to facts buried in the center of the text. They also struggle with multi-hop reasoning, where they need to connect distant facts to find an answer. While long context improves access, it does not guarantee focus. This distinction is critical for system design. There are still clear scenarios where vector databases win. If your dataset is massive, millions of documents, retrieval is essential. For frequently updated or latency-sensitive data, you cannot rely on full context ingestion. Retrieval is a fundamental requirement. But when the dataset is bounded and the task requires synthesis, like reviewing a bundle of contracts, long context wins. It allows the model to maintain logical continuity and cross-reference distant sections without losing the thread. The most practical direction for the future is hybrid, a memory layer that retrieves and a long context model that reasons. Instead of retrieving fragments, we retrieve whole documents and let the model handle the synthesis. In this setup, retrieval handles scale and recall, while the model focuses on thinking and reasoning. For builders, this shift simplifies early decisions. You don't always need a complex RAG pipeline on day one. For smaller problems, feed more context directly and avoid premature chunking. Focus on the quality of reasoning. The emphasis is shifting from how do we retrieve to how do we help the model think better. This is the future of AI system design. Bounded reasoning met with unlimited scale. To summarize, use long context for deep synthesis on specific datasets, and use vector databases for massive, ever-changing knowledge bases. As systems evolve, the synergy between retrieval and reasoning will only grow stronger. The goal remains the same: building systems that don't just find information, but truly understand it. Thanks for watching this deep dive into the future of AI architecture. Stay tuned for more insights into how technology is reshaping our world. Until next time, keep building.